welcome to the podcast. I'm your host, Ari Hirschberg, Manager Digital, Community, and Engagement at the Exchange Lab. I am talking with Marianne Bellotti, author of Kill It With Fire, Manage Aging Computer Systems, and Future-Proof Modern Ones, to continue the conversation from the Digital BC livestream with Gillian Crothers on Legacy Modernization, Part 3. Thank you for writing Kill It With Fire. As someone that is not technical, but is surrounded by brilliant people that are, I was impressed with how you were able to write for people that are both technical and people like myself with stories that connect the dots and offer a lot of aha moments around legacy modernization. During the live stream, I moderate the online questions. You have a knack for sharing information that connects with people, and our audience wrote in statements that resonated. I won't be surprised if some start entering our vernacular. We start hearing them in presentations and conversations. Some of them were, we frequently forget that any given system has a finite effective lifespan, much shorter than we've ever assumed. Team humanities with a side of tech. And maintainability is the key for stability. We have some great questions we weren't able to answer the Digital BC live stream for you today. Looking forward to the conversation. So without further ado, welcome Marianne. Thanks for being on the podcast.
Well, thank you so much for having me, and thank you for reading the book. I really am so overwhelmed by the response that it has gotten.
It was really fun to read, and I don't know if we told you or if you heard, we gave away quite a few books of yours.
I did.
And we're getting a lot of excitement. Like, we did it twice. We did it right after our last Digital BC live stream person, Honey DeCanny, spoke on Legacy Part 2. We gave 20 books away, and the people who got the 20 books ahead of time, a lot of them wrote back to us and thanked us, and they were just like, "This is so cool! It's like being in a book club, right?" Because they were like ahead of it.
Yeah, exactly.
So I'll start with question number 1. What type of thinking is required to approach designing future systems today that we will not have technical debt future generations to address or deal with?
Well, so I think that really what we don't want to do is try to focus on building perfect systems that will remain perfect for all time. That's just not the reality of how any systems behave. I think what people have to appreciate about legacy systems is that part of the story is we didn't design things correctly because maybe we made a mistake, right? But a larger part of the story is the market changed around us, the mission changed around us, the legal picture changed around us, the technology advanced in a strange and unpredictable way. And so it's natural and normal for systems that exist for long periods of time to have to go through these periods of re-architecting them. In fact, when I am working with engineering teams today, I will tell them, assume 30% of all your technical decisions will end up being wrong and you will have to redo them. Because I don't want them to spend a huge amount of time trying to shadow box with the future state, right? I want them to have deep, thoughtful, meaningful conversations about what we're trying to accomplish and the best way to accomplish that and the different ways we could implement that and those trade-offs. I want them to have those conversations, but I don't want them to get stalled. And a lot of engineering teams can get stalled trying to be too clever, trying to build so that you avoid a migration, build so that you avoid a re-architecture later on so that you don't have to break things up in order to scale them better. I do not find that to be a productive use of people's time. The things that I highlight in the book around this issue are there are issues that you can foresee and there are issues that you can't foresee. So one of my favorite class of bugs to talk about are what I refer to as time bugs. Some other engineers will know them by time overflow issues. So, and then people who are less technical will know it by Y2K, right? And so what a lot of people don't appreciate about Y2K is that was not an isolated incident. And in fact, it's not the only time that something like that is going to happen. When you're storing something like time, you don't have infinite memory with which to store that. And yet time moves on infinitely, hopefully, at least infinitely. We continue to accrue minutes and hours and days. So no matter how much memory you give to storing this little bit of information, this small piece of information about like what time is it in the history of mankind, you're eventually going to reach the point where that number is larger than the memory that you have. And then you have to figure out what to do with it, right? So that is a situation that is foreseeable. You know that it's coming, and you probably know approximately when it's going to happen. And so you should have some thought process that's going towards, like, how are we going to handle this situation in the future? It doesn't have to be, how do we solve this problem now? In fact, I often prefer that it isn't, because the longer you put off where that problem is going to come, the more likely people have completely forgotten that it even is an issue and are therefore completely unprepared for it. But you have other issues there where the time scale to you having that problem isn't clear, right? Like, I think the example I use in the book is like the running down of hardware. We know that hardware will eventually reach its end of life and need to be replaced, but you can't put a clear prediction on exactly when that's going to be. It really depends on your usage level and a lot of other conditions. So there are certain things that as you're thinking about future-proofing systems, you want to be very deliberate in how you plan and prepare for them because they're foreseeable, and certain places where you want to sort of really focus on the overall organizational philosophy and process around how we handle just repairing and maintaining systems, because you're not going to be able to put like a real clear time on it. But it is still inevitable. So I kind of push back on this notion that, like, if we're just really smart, we can avoid migrations and modernizations. They are inevitable, and we need to sort of prepare ourselves and our teams for their inevitability.
Yeah, and to that, what drew through the book for me was keeping the momentum of your team moving forward.
Yeah. I very famously repeated over and over and over when I was at the UN, the software has never finished. The software has never finished. Like these things are dynamic tools, and they're going to change as your needs change, and they need to be maintained and curated as your needs change.
So what role do incentives play in how government structures its projects? The desire for certainty, the lack of openness to pivots, etc.
Yeah, I think a lot of this I always feel like is a scaling function. I talk about an organization like the DoD, which has the Department of Defense in the United States.
Thanks.
Which, yeah, I should know better. I declare acronym bankruptcy, and so this is an organization that has so much buying power, like just so much money and so many resources, but they're at their best in terms of technology when the projects are relatively small, because there's less attention, there's less just air traffic control that needs to happen. There's more empowerment on the very lowest level of the organization. So I think oftentimes when we talk about getting real investment and incentives aligned in any kind of organization, not just government, we assume that we have to take it up to the highest level of the organization and get like all the fanfare going and the marching band in working order. And that can be good for certain problems and certain challenges. Certainly if there's a crisis, that level of escalation is generally good at getting things freed up and moving forward. But that level of attention also brings a lot of burden, and usually ends up with taking power away from the people that are the best equipped to make the really high quality technical decisions. So I think we shouldn't undersell the value of keeping and incubating initiatives in a small, safe place where we're allowed to make risk-based decisions, because the perception of the importance of this project is maybe understated, that it will be an important project eventually, but like people don't perceive it that way.
Yeah, and for someone in government to be able to work that way, it builds a muscle throughout the organization by going that way.
Yeah, there are so many government projects that I've interacted with where they were started small, almost like a skunk's work even, like they were kind of like not officially off the books, but like people didn't really know what was going on, and they were allowed to build a certain amount of momentum, a certain track record, and then we have the joy and the pleasure of taking them and kind of like moving them into these much larger conference rooms with these much more like prestigious executives and like showing them, look at this amazing thing we found in the basement of your office. Like this solves the problems you were talking about just yesterday, and it's already here and it's already built. Like that's always the most fun for me. So like those projects exist all around government. And I think that we need to acknowledge that they are part of the way that government is efficient, is by allowing those sort of things to happen.
So how would you raise the level of discourse around technology with politicians and senior public servants who still regard modernization as something for the back office team to worry about?
Yeah, I think in general, I get very nervous about trying to establish technical conversation in a place where, through no fault of anybody, the level of technical literacy is lower than you need to for implementation, right? And so what I mean by that is we saw this play out with like cloud, right? Where we, rather than having a conversation about what we're actually trying to accomplish by migrating to the cloud, we had a bunch of conversations about how great cloud was. People who are not software engineers who don't know what cloud is. And so what that did is it created this kind of lemmings-like movement of like, everything must be moved to the cloud immediately. It all must be moved to the cloud, right? Which anybody in software and distributed systems will tell you that's not always the right. There's no magic button. You just push this and everything's fine in your infrastructure. So there are definitely systems that fundamentally should not be running in the cloud, largely because of the way they handle data and need to move data around and how expensive or cheap that might be in the given condition. So I find that is not an outlier. That tends to be the trend when you try to bring technical decisions up to people who are not technical people and are not interested in being technical decisions, technical people. I find that it's way more valuable to actually make the conversation about what we're trying to accomplish. So another great example of this is what happened during the first year of the pandemic with the state of New Jersey and their unemployment insurance system. Like they had a real system failure there. And the politicians, quite well intended, tried to go out and sound the alarm about what they needed, but they misidentified what the problem was. They came in, they said, like, it's COBOL. We have all this old COBOL. It's terrible. And they got everybody, like, all of a sudden I had a whole bunch of people emailing me for some reason and emailing, like, all of these COBOL experts trying to, like, get in, like, how do we get into the state of New Jersey and figure it out? And I actually had the privilege of having an old colleague of mine working in the state of New Jersey, and I kind of called him and I said, like, it's not the COBOL, is it? And he goes, no, it's not the COBOL, Marianne. I was like, okay, I didn't think it was from what the sound of it was, but, like, I wanted to just check. But, like, that's the kind of innocent misunderstandings that tend to happen when we make the conversation on that level be about the technology and the technology choices rather than what level of performance do we need to accomplish the mission? And like, what are our options in terms of increasing that level of performance?
I like that. It does bring it back to something we talk about a lot is plain language. Okay, so is it realistic for an enterprise to attempt to build and maintain core software capabilities? For example, common components?
Yeah, it depends. So ultimately, it depends on what the organization is trying to accomplish and how common or unique that perspective is. And this would come up a lot in government, which is this, I assume why you're asking the question, is that there are lots of functions the government has that are fundamentally the same as other organizations, like HR systems, right? Like HR systems, there may be like slight complications in exactly how people hire in government, but it's not significantly different from the way the same processes work in the private sector. However, there are no private sector companies that I know of that have their own standing armies. At least I hope not. Perhaps Jeff Bezos has something in his back pocket, but like I really, really hope not. So there are functionalities in government that are quite unique to government. And like it can be very difficult to sort of retrofit that kind of functionality onto something that is otherwise really useful and well built for a commercial marketplace, like, for example, Salesforce or WordPress or any of these other like really good pieces of software that are just not intended for those use cases. So the thing that I talk about a lot with my engineering teams is the thing that we're trying to build, what is its core value add? And then what is the logic that produces that value add? And then where is that logic owned, right? Because from our perspective right now, the challenge that we're most seriously thinking about is essentially multi-cloud, how to be cloud agnostic, how to produce things that can be deployed to AWS, they can be deployed to Azure, or they can be deployed to an on-prem data center. And if our logic is enmeshed and completely dependent on something that's very specific to AWS, then we can't do that. So that's the kind of calculation that we go through with this conversation. But the same conversation is relevant when you're trying to figure out, do we build or do we buy? You want to figure out, like, what's the value add? What's the logic that backs that value add? And then you want to look at the available options and go, do they have that logic and do they bring that value? And sometimes the answer is going to be no. And when it's no, you're probably going to be better off building a system internally that actually suits your needs than you are going to try to buy something that's out of the box and then just like hack it to death until it does.
Thank you. We as a species like to compare sports teams, Coke versus Pepsi, PC versus Mac, to name a few. New solutions versus the old is a common comparison when working with legacy systems. Existing systems define a sense of completeness and totality, impede our imagination or what might be or should be. What are your thoughts on real tactics to respect the past while breaking away from this type of thinking?
I like to direct people to what is the motivation behind that kind of thinking. Because a lot of times it's these very understandable, very human, and in some ways I would say very charming instincts, right? Like engineers are intellectually curious. They want to play with new stuff. They want to play with cool new stuff that other people don't know about, so that they can know a lot about it and then show off to like their colleagues. This is a very natural instinct, right? And so a lot of times when an engineer comes to me and goes, look at this cool thing I did, we can configure this, do this, like, and arrange this, and we hook it up here, and like everything works really wonderful. Like my first question is, what problem is this trying to solve, right? And like, can you articulate clearly for me what problem this is trying to solve and like why this is the best solution versus something we already have or something slightly less glamorous, maybe a little bit older. And kind of pulling the conversation into that space helps temper a lot of like the misdirection that we get from like focusing on new technology and like shiny brand names versus like the old technology that's already there. If an engineer cannot articulate to me what problem a certain infrastructure is trying to solve or a certain tool is trying to solve and cannot give me some like actual tangible standards of like how they're judging and assessing why this is the best solution versus something else, that's a red flag. That to me says like this is probably a waste of time and money. And so generally what I will do is I will set expectations and give them a little bit of time to go back and like actually develop that story. Because it may be that the value add is there and no one's ever asked them that question because everyone is so obsessed with how shiny and new this is. And that they just need a little bit of time to think about it and document it. And then once they've got that, then we're good to go. Or it may also be that when they're forced to confront it, they realize that actually the juice isn't worth the squeeze on this one. And so when we are continuing that conversation, I will also talk about like who's going to maintain this thing, right? This is a constant issue with introducing new technology. We know we have to do it, right? We cannot live in a time capsule frozen with wherever we started on the project. We're going to have to eventually like introduce new technology. And we also know that that process means we're going to have to figure out how we're training people, how we're cultivating that experience with them. If we're hiring more experienced people to join the team, we've got to solve all of those issues too. But we don't have to do it all the time, and we don't have to do it at every opportunity. So we really need to be able to have a conversation about like, what are our expectations about this? Are we going to retrain the entire engineering team in this new technology? Or do we feel like that actually wouldn't be worth the cost and time and money that it's going to take to do that. And so we might not want to use this new technology, right? These are all really interesting conversations to have with engineers, but they're not pure engineering conversations. So they require people to work well across the different silos in an organization, because you need to be able to articulate, we want to spend this money and this time doing this thing. Like, how does that impact everybody else in the organization as well? And so this is why people struggle with it, because they tend to see themselves in a lane as like technical or non-technical. You do sort of have to be able to cross over to do these strategic conversations.
And do you want them in the room on a regular?
I mean, I think that we shouldn't wait until we have a decision to talk to our peers in the mission-driven or mission side or business side of the organization, right? There should be a regular conversation that's being had with these parts of the organization. There should be regular relationships that are being built with these parts of the organization. And then when we are at the stage where we actually have a project that affects us both, then we need to sort of negotiate how those decisions are going to be made and how that communication is going to happen. There are cases where, like, I've actually drawn up a charter saying, like, these are the things that this is the process that we're going to have in place for operating this joint effort. These are the types of meetings we're going to have, and these are the people that are going to be invited to it, and the way people are going to get to contribute to each stage. So, like, don't be shy about it, and don't assume it'll all just work out because we all want the same thing. Because you do all want the same thing, but it does not, like, people don't work together well all the time.
Thank you. Any final thoughts or anything you want to leave us with?
Yeah, I would say that modernization work is really hard work. I have incredible admiration for anybody who chooses to do it. It's also really fascinating work. I've always really loved the kind of socio-technical space. And so for me, the fact that this does involve a lot of how people see risks and how they process incentives and like how we communicate with one another was a plus. It was the thing that made this work more interesting. It was like, oh, it's technical work. And also there's this interesting like person challenge on top of it. But it is definitely, I think the expectations for modernization work have to be that it's a long game, right? And by that, I don't necessarily mean that it's a 10-year project, but that you have to have a very long view. You have to know this is a thing that's going to regularly be part of the conversation. And not something you're just going to bang out in 6 months and then go back to like whatever it is you really wanted to think about, right? That this is something you have to sort of regularly think about in terms of how are we keeping our systems as healthy as possible. And so appreciate that challenge in front of you and appreciate what that means for the people who are going to be actually implementing the modernization effort. And I think you're going to be on the right side of things.
Wonderful. Thank you. So thanks again, Marianne, for taking the time to share your thoughts, and thanks for listening to our audience. Hope you enjoyed this episode on Legacy Modernization Part 3 with Marianne Bellotti, author of Kill It With Fire, Manage Aging Computer Systems and Future-Proof Modern Ones. I'd love to hear your feedback, comments, and suggestions. You can connect with me at ari.hirschberg@gov.bc.ca or click the link in the show notes. Thanks for listening.